this talk won't be a sales pitch about Keycloak, I promise. Although I will tell you a bit about it towards the end of my talk. We'll use it as an example. So what I will tell you about, I will try to explain what are the problems with security nowadays and how things changed. I will tell you about a bit about token-based security and why tokens matters in most of security standards and why you should care about tokens when you do things with security and why you should understand them. I will try to dive a bit more into 4 different standards. So SAML2, JOT, JSON Web Token, or JWT, OAuth2 and OpenID Connect. And then towards the very end of my talk, I will try to explain how you can simplify your life a bit by using out-of-the-box solution, or shield yourself from legacy infrastructure by using identity brokering and stuff like this. Okay, so let's start. In old days, everything was simpler. That's for granted. But we all know that applications many years ago were usually server-side, which it doesn't mean that they were more secure, but security area for us was a little bit simpler because our applications were much more simpler. So things were collocated like web, logic, and data layer. And usually, if you think about security in such applications, it was really a form-based one. So you collected credentials via the form, you computed a hash compared with the database, and that was pretty much it. So usually everything was server-side, password-based, and session management was fairly simple because we had HTTP session on the server side. When we wanted to log out user, we invalidated the session, we were using cookies. Things changed because security in the application is not about a simple form with credentials anymore, and we have many different types of applications. Passwords are problematic. They are very problematic to pass them around to propagate security information. Usually every few months or every month nearly there is a major security breach. And what's funny is that even though we have all of those best practices and a lot of great knowledge, and those companies were keeping passwords in a proper way, they were properly salted and peppered and whatever else. A few weeks after the breach or months after the breach, researchers are usually able to recover most of those passwords, and they find out that most of them were really bad. We have new credential types, and older applications are usually hard to adapt to use those new authentication mechanisms like biometric stuff or one-time passwords and so on. Session management is certainly much more challenging, especially for mobile and HTML5 applications. Users are used to using stuff like Facebook, Twitter, or external authentication providers. And it's not only about users using Facebook, it's also about business-to-business relationship and cloud scenarios where we need to give access to users from external organization into our resources, our partners. Single sign-on is a very common requirement nowadays, and there are ways to solve it. What's much more challenging is single sign-out. So there is an expectation that you can invalidate all your present sessions in many different applications in a single place. When you think about mobile devices, sometimes users just pick up their phone, like very rarely, and they open some application, and they expect to be authenticated there. They expect to remain authenticated there. Mobile devices are a very bad place to store credentials. They are not a very trusted place. And even if you do so, if you lose such device, the only way to cut off access from this device would be to change the password, which is not a modern way to do things. So there are many different reasons like that. If you're interested in this topic, you should certainly check out the OWASP. It's the Open Web Application Security Project. They have a lot of great materials, like well written and very easy to read about best practices you should be aware of when you're doing security stuff. Every few years, they publish a report called Top 10 Most Critical Application Security Risks. In the most recent one, the number 2, was broken session and authentication management. And what you can get from this report is that it's not really a good idea to try to implement it yourself. You should rather rely on something which people worked out and invented already, which is tested. So when you think about most of standards and solutions and approach to security, the very most common pattern in all of them is that you see tokens, usage of tokens. And it's actually, this reflects what we see in the real world. In the real world, real physical world, ticket, token assertion, that's basically a physical stuff which is a proof that we are entitled to access something or use something, use some services. And this is very same in digital world. So token in digital world is some document in some format, having some payload, so information about us, our organization, the roles we have, authentication mechanism we use to authenticate, when this happened, and so on. Tokens are usually signed because this allows us to be sure that they were not tampered, so no one altered them somewhere in between during the communication. And this also allows to reduce communication overhead, because when we obtain such digital token, by checking signature, we know that we can trust it, so we don't need to communicate with the issuer to check. Why tokens? Tokens are very good because they allow us to decouple authentication and authorization methods. And those methods really depend on what is the application type, what is the environment, what is the scenario. And they are very easy to pass around. They are very flexible because we can develop our own contract and can decide what should be in such token. So we can add a lot of additional information there. We can define lifetime of the token, how long it should be valid, and we can invalidate it and we can manage it in a central manner. Still, why tokens and why they help? The key part about token is that you can delegate authentication into one single dedicated and trusted server provider. So providing credentials happen in a place we trust and we are sure it's secure. So the most typical picture when you think about modern security architecture is like very high-level one. That's basically it. So we have authorization server or identity provider, so the place you authenticate with. It issues you a token. And then your applications of different kinds can use this token to access services. The most important part is here. Tokens are flexible, they can be passed around differently. So if you're implementing service free, I'll tell a bit more about it later. You can just teach the service how to read the token and which information the token to check. And that's, from your point of view, that's all you care about. And this makes the whole security much simpler for you to cover. So typical components which you witness is identity provider or authorization server, depending on the specification. The place which stores user data, performs authentication, issues and verifies and revokes the token. Then you have service provider or resource owner, so you, basically. Someone who owns the data and exposes endpoints, so API usually, to access it or perform some operation on it. And then user, client, relying party. So you, via the browser or some application, you configure to do something on your behalf. How does it work in practice? Let's say you work in Acme company, and they decide it's too expensive to host their own mail server, so they will use corporate Gmail. To do so, they will just pass Google a token to prove that their users can access Google services. So what happens here is that your employees, Acme employees, put their credentials on their trusted server within company firewall and VPN. Then the token is being passed, and they get access to Gmail without providing Google with any credentials. and Acme remains in control what kind of informations about their employees are passed to Google. And it really works like this for most of modern applications and most of like software as a service providers and companies like this. This covers Web SSO, so accessing different web applications without providing your credentials twice. And in more general, this is called federation. So between two organizations, you have a trusted relationship. Standards which covers this is SAML2, which is around for 10 years now, and it's a very mature standard. It's based on XML tokens, which is quite verbose and heavy. It covers a lot of different profiles and pretty advanced scenarios. You can secure SOAP calls with it. And it's very mature and very widely adopted. The downside is that it has fairly high learning curve and that it doesn't fit mobile use cases well. The major issue it solves is federation. So you form a trusted relationship between two identity providers. So authentication and authorization between different organizations. And if you will do anything around security with already existing infrastructure, we will for sure need to work with SAML2, because every product on the market or every solution on the market in the identity space supports SAML. It's so well established. What is the issue with the SAML2 and mobile? You probably would like to know this. It's pretty ironic. When they were developing SAML, they decided that passing a token will happen via the post call. And in a mobile world, it's much more handy and convenient to pass it via get call. And well, oversimplifying a bit, but that's the root cause. There are ways to work around it. There are some standards and proposals or technical solutions to work around, but workaround remains a workaround. So SAML doesn't really fit mobile very well. It's always with some hacks. Then we have two newcomers, so modern standards, OAuth2 and OpenID Connect, which I would like to tell you more about. And those were designed to solve modern security needs. So mobile applications, client-side applications, stateless ones, services and APIs. But first of all, before I start explaining more OAuth2 and OpenID, I will briefly go back to tokens, because I believe it will simplify a lot of things for you if you just know how it looks like and how it works. There are three major token standards which still matters. Kerberos. So Kerberos actually is a default authentication mechanism in Windows. So every Windows domain uses, and you're using it on your Windows laptop. SAML2 and JDD JSON Web Token, or JOT. I'll just focus on the last one because this is the one relevant for OpenID Connect and OAuth2. So JSON Web Token is one of 5 standards forming a family called JSON Object Signing and Encryption, which is an RFC standard. It's just worth knowing that if you need to do anything security-wise with JSON objects, there is a wide variety of standards and frameworks and libraries to get you covered. It is a JSON document, so key value per, where value can be another JSON document, and it has a wide choice of signing algorithms. So in a nutshell, it's a simple JSON encoded in base64, and it contains 3 parts: header, payload, and signature. Let's see the example. So header is just information about algorithm being used and token type. Then payload, first 2 attributes are defined by the spec, which actually it's quite simple. It's not a very long spec. You can easily read it and understand it. The last 2 ones I just made up. You could make authorization decision based on those. So we take a header and we encode it in base64, and then we put it here, and we place a dot. Then we get the payload, we encode it in base64, we put it here, and we place a dot. And then we take the whole part, so header plus payload, we make a hash, and we put it here. So it's header base 64 dot payload base 64 dot and signature, and that's basically it. So really, JSON Web Token is not a complex thing, and it's very convenient token type to use because it gives you a lot of flexibility and power, and it has a lot of already provided libraries and so on to work with. OAuth2. Okay, so who knows or ever used OAuth2? Raise your hands. Okay, like 1/3. So this is a prank, because everyone here used OAuth2. So if you have ever logged into any web application using Google or Facebook, you have used OAuth2. If you have ever witnessed a screen like this, some application asking to get access to your Google profile, you used OAuth2. This is clearly defined by the spec. And if you have ever configured your mobile device to connect to Facebook, it's also via OAuth2. Some facts. It's a standard developed by a lot of major companies together. There used to be a version 1.1 and 1.1. Actually, Twitter, I think, if I recall correctly, is still on 1.1. But version 2 is not compatible with 1.x. They're just based on previous experience, but they rewritten it from scratch. And it focuses on mobile apps, client apps, services, and so on. So what are the major use cases? The key thing to know is that this protocol is not for authentication. So now you may think, okay, not authentication, maybe authorization. It's not for authorization as well. Although OAuth, the out part in OAuth actually is for authorization. But OAuth is a delegation protocol. So key thing OAuth covers is that it allows applications and services acting on your behalf to do some stuff with your resources. So you have a few actors here: resource owner, so you usually. Client, so application, resource, so APIs, exposing your resources, and authorization server, so the place you authenticate into and which issues a token. The power of OAuth comes from few angles. So it defines different authorization flow depending on what is the application type. So we have server-side applications with authorization code flow, client-side and mobile implicit flow. Resource owner, so you as a resource owner can just exchange your credentials for a token. Or application also can have identity, and it can obtain a token for itself. So this is the fourth one. Let's take a deeper look at the first two. So authorization code flow. Let's say you have an application which wants to, it can be a server-side one, for this flow. It wants to get access to your resource on Google Plus or Picasa. So you get redirected to authorization server. In such case, it's Google. You get redirected back after you authenticated. An application obtains authorization code. Then application sends to authorization server authorization code plus its own credentials, which were previously registered in authorization server. And in exchange, it gets access token and refresh token. So access token is something short-lived, which you can use to access the resources. And refresh token is something long-lived, which you can use to obtain a new access token. Then you use access token to access the resources, and that's it. Implicit is much simpler because it's client-side. So we don't want to store things here. So we just, after authentication, it obtains access token and it uses the access token to access the resources. Another powerful thing about OAuth is the scope. So you probably witnessed it when you logged into some application with Google or Facebook. You probably were asked if you want to give this application full access to your Facebook wall to post on your behalf, or you want to just give it a very basic profile info, so your user, your name and email, and that's it. This looks like this, and this is also defined by the spec. OAuth2 can have different token types, so they can contain real values, or they can contain a reference to values. This is handy when you know the token will leave your trusted network, and you don't want the token to contain the information outside of your network. So you can put reverse proxy in front of your APIs and then swap the token for the real one. So to summarize, OAuth2 is pretty generic standard. It doesn't define a lot of things. It doesn't define the specific token standard. So you could actually use OAuth2 with SAML2 token. There is an RFC for that. It lacks a lot on the authentication side and on user info side. And therefore, many people consider OAuth2 not really a protocol. They consider it a protocol framework because there are so many things undefined there. The plus is that it scales and adapts nicely because really, if you want to implement a microservices using this stuff, all you need to do is to teach your microservice how to recognize and understand information from JDD token, which is pretty flexible. Another one which you should be aware about is OpenID Connect. So this is actually one of the standards which takes OAuth2 and builds on top. It adds 2 new flows. It adds a lot of around session management, so single sign-on and sign-out for HTML5 applications, which is pretty cool. So we can have several client-side applications, and then you can log them out, all of them instantly in one call. It adds ID token, it adds user info endpoints, and if you think about cloud provisioning scenarios, it allows auto-discovery and client self-registration into authorization server, which simplifies the provisioning a lot. This is getting very widely adopted. SAML2 won't go away anytime soon because it's so well established on the market. Although I think that OpenID is something which will slowly replace it. And if you hear like big companies, Microsoft, Google, and so on, preaching their infrastructure for cloud, what they advocate using is this. So 95% or 99% cases, if you're developing some new modern applications, OpenID is something you should primarily consider for authentication and authorization. Now you may ask, okay, but you tell us about all this new cool stuff, modern stuff, but we have a lot of legacy. How we should approach them? So here I will do a shameless plug because I will mention Keycloak project because my team works on it and I think it's the best thing on the earth. Although I will just use it as an example. There are other solutions on the market doing similar things and same concepts apply here. So Keycloak is basically authorization server in OpenID Connect sense. So we put it here, if you remember the big picture. One of the killer features is identity brokering. So we can use it in a way that you integrate your applications with Keycloak, speaking OpenID Connect or SAML, and then Keycloak can integrate a lot of other providers. So it can integrate external SAML identity provider. So here goes your legacy infrastructure integration, and here goes your modern stuff. It's same if you have already LDAP or Active Directory Windows domain in place, and there is SPI to plug servers like this. So Keycloak can handle all the legacy integration for you. Another thing you could consider is to try to externalize most of security outside of your application. You could integrate with out-of-the-box solution. And that's kind of the direction you may find interesting if you consider all the advices from OWASP, because doing things in your application in security space means you have a lot of things to implement in the wrong way. So security is hard, so the general rule is don't try to re-implement things yourself if you can use something trusted and already tested by people. And if you consider the global picture, this approach just makes sense because like a modern security architecture is just like this. You need this kind of external and centralized component. How does it work in practice using Keycloak as an example? So it can be pretty minimal. If you consider a client-side application, a HTML5 application, you just use JavaScript library, you put this code snippet, you have a login button on a page, and that's pretty much it. And you have many different client adapters for different types of technologies and frameworks, and it's actually not that hard to develop a custom one as well. What do you get in exchange? If you click on this button, you will get redirected to the login page hosted by Keycloak. It is not that hard to implement yourself, I know. But then if you go to the UI console, you flip some switches there. Then you go to the other part of the console and you add external identity providers and social providers. And suddenly your login screen looks like this. So suddenly, within minutes, you have Remember Me feature. You have new user registration feature. You have external authentication sources, somewhere you can either use their token or redirect your users there to authenticate, then come back and go into your application. And social providers. Obviously, you would probably want this login page to look like integral part of your application, so your users are not really aware that this is something external. And sure, you can develop a skin, a theme, and for example, it could look like this, like totally different. It's very flexible. Then you may want to plug some step into the whole authentication, like they need to agree on terms and conditions. And you have this, and it's not only this out of the box, but there is an SPI and there are hooks, so we can add additional steps. And you can configure the order and how it works in the UI live. User self-management, this is another typical case. You want your users to not go to you, but change their password themselves, change their profile themselves, look where they are logged in, and in a central place, let them log out from all their current sessions. And that's also available, and you can skin it. For example, OTP, one-time password, they can configure it with Google Authentication and much more. I won't go further with this. Those are just some possible features you get for free, like user impersonation. So you can click on a button, and as an administrator, you can start acting as a user to test things, and so on. Those are all the things that you could implement badly in your application and in an insecure way. So what does really remain for you? You still need to configure the client adapter. You need to get more information from the token if you want to make authorization call. And then it's also pretty flexible because if Keycloak or solution like Keycloak is configured with like social, Facebook, Twitter, and so on, you will also get tokens from them. So then you can do a mapping. So information from those tokens are put into Keycloak, into token issued by Keycloak, and you can have all of this in a single package altered by you. And then there are also additional operations you would like to use and so on. Okay, so summarizing. If you're doing something in security space, it's actually very important that you rely on existing standards and not try to come up with something of your own flavor. So in your case, the current modern ones are OpenID Connect and OAuth in general, and they will most likely fit your needs. You should try using existing frameworks, libraries, and out-of-the-box solutions. This will speed you up to a great extent. And you probably know that in every application, you need to develop the very same stuff for user management, for security, and so on. And if you, well, there is a single message I want you to remember. Don't try to reinvent or invent things yourself in security space. Because usually it's quite a bad idea unless you are really expert in this field and you're really focused on coming up with something new and modern. So I hope that all of this helps, and that's all. I tried to keep some minutes for questions.